Brady watches this.
Hey, Brady, we started going and then I forgot to record. So we're on example 7. We did example 6, which looks like this. And we did example 5. If you want those guys, whatever, you can pause. But here's example 7. Graph a piecewise function. All right, now we're graphing 2 more pieces. And where does it switch from the first piece to the second piece? -1. So I'm going to like put imaginary dotted line on my -1 right here. That's where he's going to switch, okay? The first equation is y equals x plus 3, which is which type of function? Linear, right? I'm going to start graphing that at 3. And it goes up 1 over 1, up 1 over 1. Oh, but wait. I'm supposed to be graphing on the left side, right? So I'm going to do this. Whoop. And where he touches is less than, so it's going to be an open circle right here. Yeah? So I'm going to get rid of my other dots. Doop. Okay, good? All right. Now I'm graphing y equals x squared. Okay, y equals x squared is a parabola that's centered at 0, 0, right? Parabola starts at 0, 0. And x squared is a parabola. He's going over 1, up 1, right? 1 squared is 1. Same thing over here. 1 squared is 1. 2 squared would be 4. 3 squared would be all the way up at 9. But this one is kind of funny, weird. I don't have an arrow that goes forever to the right. Do you see that? He stops at 2. Make sense? Okay, so he's going to be an open circle on 2, a closed circle on -1, and he's going to look like this. Doop. He will not have an arrow that goes forever to the right. I'm going to erase my dotted line now. Yeah? Good, good? Okay, now here's my question to you.
What's x or what's y?
Is it a function?
What is f of 4?
Undefined.
Undefined. Because we do not have a domain for 4. It only goes to 2. Right? If they would ask for the domain of this thing, the domain is going to be from -infinity up to 2 with a bracket or with a paren. Because we only know what happens up to 2. Does that make sense? Okay, we do not know anything that happens beyond 2. So if they ask for something beyond 2, what? Yes. Because, so even though they are 2 separate pieces, we are touching every x coordinate on the domain. Does that make sense? Even the place where they swap, right? I do have a value at -1. He does have a closed circle at -1. So that's why even though there are 2 separate pieces, I can treat my domain as one piece because he will touch every dot on the x. Yeah?
Always have to have a closed circle at where they switch.
They don't have to, but usually they will. Yes. They don't have to. It would just be like a discontinuous point there, like where nothing lives. A hole. Yeah. Yeah. So it doesn't have to, but usually, like for a piecewise function, usually they will. Okay, good.
Light work.
All right. Example 8 is the greatest integer function in the Trig book. This is what the greatest integer function looks like. He has 2 brackets like this. In the calc book, the greatest integer function is 2 double lines. It looks like a double absolute value. Those are the same thing. I don't know why in separate textbooks they treat them separately. But here's what the greatest integer function does. Greatest integer function is also called a step function. Step
Are you sure?
function.
Are you sure that y doesn't equal 121?
What are you talking about? Whatever. Okay. It's called a step function. It's what a greatest integer function is. All right, now here's how a greatest integer function works. Let me just graph it for you. Here's what a greatest integer function looks like. Okay? This is the parent function of a greatest integer function. Okay? When you are born, you are 0 years old. Yes? And when you are a half of a year old, you are still 0 years old. And when you are 0.9 years old, you are still 0 years old. And when you are 364 days old, you are still 0 years old until you get to 1 year old on your birthday. And then you hop up to 1 year old. And you are 1 year old for that entire year. Even if it's the day before your birthday, you are 1 year old until you hit the 2 year old mark on your birthday. And then you hop up to 2 years old. Whatever. It doesn't matter. Then you hop up to 3 years old. This is what the step function looks like. Okay? Oh gosh, I can't see my arrows.
Get it? Because there's steps.
Yep, there's steps. And it also goes down negative as well.
Yeah, if we're doing this.
But that's the best way I have to explain to you that like it stays that way for the whole year. So basically a step function, write this down. You always you always round down. You always round down. So if they ask for, like, here's some examples. What is the greatest integer of 3.9? 3. You always round down. Even though 5 and above, blah, 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 we don't do that. You always round down, because if you are 3.9 years old, you're still only 3 years old, right? You could say you're almost 4, but you're 3 years old, right? Okay, now, here's where it gets confusing. Negative 5.1. Greatest integer. Ooh, negative 6. Because rounding down negatives, you round down to the next full number. Oh, a lot of people say negative 5. Nope. Negative 6 is the number that's lowest, or you're rounding down to. Does that make sense? Yeah? So negative numbers get a little bit more confusing. Good?
That's
Yeah?
That's
Move
slow.
on. I'm
That's
tired of this
slow.
stuff.
Okay, greatest integer. We don't do a lot with greatest integer function. It doesn't appear very often, but I need to introduce him to you because sometimes you will see him, okay? Whatever. Now, let's say they do like 2 greatest integer x, right? Okay? That's going to vertically stretch him by 2. So rather than them being there, like this one will still be here, right? But the next one will be like here at 2. Then the next one will be here at like 4. Does that make sense? Okay, so it'll be 2 tall, right? Let's say I do like this. 1/2 x. Do you know what he looks like? That's a horizontal stretch by 2, right? So how does that work?
They go 1 to 2.
So he goes from 1 to 2. And then he goes from 2 to 4. Then he goes from 4 to 6. Does that make sense? The blue one is going to be a horizontal stretch. The pink one is a vertical stretch. Yeah? That's how he works.
We still got 2 pages.
Okay? Good?
Yeah, I'm gonna hurry up.
Yeah?
Pages. We're about out of time.
Okay.
I'm
Okay.
gonna get done with homework.
Okay, example 9. Use a piecewise function. A salesperson makes a monthly salary of this much along with a 5% commission on sales as long as they are over $20,000 a month. Okay. So, my piecewise function. Use a piecewise divide function to represent the sales monthly income in dollars, blah, blah, blah. He makes a sale of $3,000 along with 5% commission. Now, what does that look like as a function? Yeah. But don't worry about the 20,000. Per 0.05 is your commission, right? Times X plus the 3,000, right? And I get that, and I plug my X in as long as X is greater than or equal to 20,000. Does that make sense? That's your domain for that one, right? What if X is less than 20,000? Does it say?
You just get 3,000, don't you?
Because
you wouldn't get your commission.
Right, a piecewise function to, it doesn't say though.
But it says along with.
Okay, so with, yeah, that makes sense. So 3,000 probably for X's that are less than 20,000. Yeah. Oh, but wait, over 20,000. So the equal to should go here and not here, correct? You have to be over 20,000 in order to get commission.
Zach, maybe that's
Over 20,000 would be like not equal to 20,000. Okay.
No.
Now, typically we want to graph like the lesser ones first. So like these 2 equations should be switched around, but it doesn't have to be. Right? Like that one should have gone first numerically because that's what happens first. Whatever. We don't care. Okay, good? Make sense? That is what my piecewise function looks like. We can call him P of X or whatever. Or I of X. Oh, they call it I of X. I of X for your income. Yeah? Okay. Good? Have we done increasing, decreasing, constant yet? Love it. All right. Next thing, increasing, decreasing, constant. Increasing is going up from left to right. Decreasing is going down from left to right. Constant is staying the same. Yeah? Okay, now, here's the tricky part. Let's analyze this graph. You are only looking at the x coordinates. You are only looking at the x coordinates. So abouts right here at 40 is where he switches, right? So if I'm talking about the graph, he is increasing first from 0 until we get to 40. Now, I am going to put a parenthesis on 40, okay? And then the very next chunk is going to be constant from 40 until we get to about 120. And I'm going to put a parenthesis because at 40 exactly, he is neither increasing nor constant nor decreasing. So each one of these times I go through, he is a parenthesis. Does that make sense? At those places where he changes from increasing to decreasing to constant, whatever, he is neither increasing nor decreasing. That's why you don't use a bracket. Make sense? Yeah? Okay.
And
Hold
we're
on.
cooked.
No, we're not. He just gotta come back. He just gotta come back. He just being angry with me right now.
That means you gotta restart your.
No. Done this a bunch of times. Now, it would be really nice if he would just connect using AirPlay, but we're really crabby right now. So we have to just be nice. I know it is recording, yeah. Decreasing. He's decreasing from what to what?
120 to 160.
From 120 to 160. With parentheses, not brackets, because at those places exactly, it is neither increasing nor decreasing. That's why we don't put a bracket. Got it? Yeah? Okay. Determine the intervals for which the function is increasing, decreasing, constant. It is easy to lose track of where you are, so I just go in order from left to right. So what's he doing first? He's decreasing from what to what?
-4 to 1.
From -4 to -1, he is decreasing. Okay? Then he is constant from what to what? From -1 to 2. He is constant. Then he is increasing from 2 to 3. Then he is decreasing again.
3, 2.
So I go union, because there's 2 sets of it, from 3 to infinity, done. I just go in order, right? That way I don't lose a chunk. Got it? Not too bad? Yeah? That was example 10, and now we have maxes and mins. Perfect. This is going to lead so well into what we're doing next in calculus. You guys are going to love this. Like, actually, really. We do increasing, decreasing, maxes, and mins, but we do them with derivatives. You're going to love it. You're going to love it. I love it. I love it. I love it. Okay.
Find the derivative now.
A maximum. A maximum is a high point. A minimum is a low point. They call them relative because relative means in relationship to all the points around it, it is a low point, right? In relationship to all these points around it, it is a low point. Now, there is a difference between a relative max and min and an absolute max or min, right? Absolute max, absolute min. For example, this guy right here is not an absolute max because it is not absolutely the highest point on the graph because this guy will continue to go up from there, right? You can even see this point right here is higher than that, right? So he is not an absolute max. You will maybe not always have an absolute max because if he continues going up forever, you won't have an absolute highest place. He won't ever reach there, right? This guy, assuming he continues to go down forever, this is not an absolute minimum, right? It's just a relative minimum.
If it oscillates.
If it oscillates, then you will have like an infinite number of absolute mins, right? And relative mins. Those absolute mins will also be relative mins, right? But you will have an infinite number of them if he's oscillating, right? Like if he's doing this and they're all the same height right here, like all of those, okay? All of those going across, they will all be absolute and all be relative because they're all at the same point, okay? All right, find the relative max and min. Determine the location of any relative mins. How many relative mins do I have? You have -5, -1, and,
That's max.
yep, but he's still relative. All absolutes are still relative.
Yeah, but that says max, not minimum.
Oh, max, I'm sorry. Blah, 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 blah. -5, -1, and 4, -2.
Why do you
Those are my mins, and
count that one?
2, 1.
Why do you count
So
that
even though this one is lower than that one, they're still relative mins because they're like little valleys. Relative just means in relationship to these little points around it, it's a low point. In relationship to these little points around it, it's a low point. Now, this one is an absolute min. What about an absolute max? There is none. This one won't have an absolute max, right? Because this high point is not going to be the highest point, right? So this one has an abs min but no abs max. Got it? Yeah? Okay? But those are the relative ones. Good? That is all. That was a lot.
Well said.
Well said, feline.
Beautiful. What is that? Go back to the front page. It has like, okay. Interesting. It's a weird looking thing. Yep. Okay, bye Brady.
Weird looking.
Vaughn?